Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed first 6 questions from exercise 12.2. Hope you have revised well. In today's session, we shall discuss the remaining problems from exercise 12.2 and few problems from the miscellaneous exercise. Let's move on to the topic. Move on to question number 7. A company manufactures two types of novelty souvenirs made of plywood. Souvenirs of type A require 5 minutes each for cutting and 10 minutes each for assembling. Souvenirs of type B require 8 minutes each for cutting and 8 minutes each for assembling. There are 3 hours 20 minutes available for cutting and 4 hours for assembling. The profit is rupees 5 each for type A and rupees 6 each for type B souvenirs. How many souvenirs of each type should the company manufacture in order to maximize the profit? Let's go through the question again. A company manufactures two types of novelty souvenirs made of plywood, type A and type B. So type A require 5 minutes each for cutting and 10 minutes each for assembling. Then 5 minutes for cutting and 10 minutes for assembling in case of type A. And in case of type B, 8 minutes for cutting and 8 minutes for assembling. And the total availability of time is 3 hours 20 minutes. So 3 hours 20 minutes for cutting and 4 hours for assembling. That is the availability for us. Then the profit is rupees 5 each for type A and rupees 6 each for type B. So we have to find out how many souvenirs of each type should the company manufacture in order to maximize the profit. So here the question is to maximize. So let's take X and Y, the number of souvenirs of type A be X and the number of souvenirs of type B be Y. And let's write down the main points to formulate the constraints. So here there are two types of work they are telling. One is cutting and another one is assembling. When we go through the question, it says about two types of work. First one is cutting and the second one is assembling. And here type A requires 5 minutes of cutting and 10 minutes of assembling. Here it is in the second line it is given. Souvenirs of type A require 5 minutes each for cutting and 10 minutes each for assembling. So cutting 5 minutes and assembling 10 minutes. And in case of type B, 8 minutes of cutting required and 8 minutes of assembling also required. And here the total availability of time is 3 hours 20 minutes. 3 hours 20 minutes in the sense when you go through the given conditions here, everything is given to you in minutes. So you have to convert that 3 hour 20 minutes into minute. So 3 hours means 3 into 60 minutes plus again additional 20 minutes. So 180 plus 20, 200 minutes. So the availability is 200 minutes. And the next case also it is given to us 4 hours. It is quite easy for us. 4 hours to how to convert to minutes, we know that. So 4 into 60, that is 240 minutes. So one I have shown. Then next the rest of the calculation you can do mental calculation. It's not a problem. Then let's write the inequality 5x plus 8y. Here 5 into x number of souvenirs of type A and 8 into y number of souvenirs of type B. And the total time availability is maximum 3 hours 20 minutes, that is 200 minutes. So it should not be more than 200 minutes. So that we have put as less than or equal to. So 5x plus 8y less than or equal to 200. And in the next case, assembling case, 10 into x number of souvenirs of type A and 8 into y number of souvenirs of type B. So 10x plus 8y is the total time. 10x plus 8y less than or equal to 240. The maximum time available for us is 4 hours. 4 into 60, 240 minutes. Then as usual there are two constraints, x greater than or equal to 0, y greater than or equal to 0. As common we have taken because both must be positive. X and y must be positive or 0. Then profit on type A, it is given to us 5 rupees 5 and profit on type B is rupees 6. Here it is given the profit is rupees 5 each for type A and rupees 6 each for type B's units. And we have to maximize the profit. So maximize Z is equal to 5 into type A is having X number and type B is having Y number. So 5X plus 6Y. Subject to constraints, we have to write down all these constraints together. That is 5x plus 8y less than or equal to 200, 10x plus 8y less than or equal to 240, and the common constraints x greater than or equal to 0, y greater than or equal to 0. Now we have to plot these four inequalities on the graph sheet, and we have to find out the region which satisfy these four inequalities, and the corner points we have to find out. By using those corner points, we have to find out the maximum profit. Next, we have to find out the table of values for plotting on the graph sheet. The first inequality is 5x plus 8y less than or equal to 200. We will take it as an equation. 5x plus 8y equal to 200. Let's find out the values of x and y. As before, x, when we put 0, x 0 means 5 into 0, 0, plus 8y is equal to 200. So y is equal to 200 by 8 is 25. Next, we can put y is equal to 0. When we put y 0, this term will be 0. 5x is equal to 200. So x is equal to 200 by 5, that is 40. Next is 10x plus 8y less than or equal to 240 is the inequality for us. But we will take 10x plus 8y is equal to 240. We have to take it as an equation. So find out the values of x and y. When x is equal to 0, this term is 0. So 8y is equal to 240. Y is equal to 240 by 8, that is 30. Next, y we can put 0. When we put y 0, this term will be 0. So 10x is equal to 240, x is equal to 240 by 10. That is equal to 24. So the table of values are ready. Let's plot it on the graph sheet. As before, x and y values we have to plot. For that, x-axis and y-axis we have to draw on the graph sheet and mark the points as 5, 10, 15, 20 up to 45. And on the x-axis also same thing, 5, 10, 15 up to 40. Then here first value is 0, 25 and 40, 0. 0, 25 means 0 is here, 25 is this one. 0, 25, first point is here. So you have to mark this point, and then 0, 40. 0, 40 is here. So by connecting these two, we have to draw a line, and we have to find out the region which satisfies the inequality 5x plus 8y less than or equal to 200. For that, as we know, we have to take a point 0, 0. It's a common point and easy also to verify. So 0, 0, if you take left side completely 0. So 0 less than 200. A true statement will get. That means below the line is wanted region for us, and label the region 5x plus 8y less than or equal to 200. And the next point is 0, 30. 0, 30 means 0, 30. It comes here. And the next is 24, 0. 24, 0 in the sense here 24 means here will come. So you have to see your graph carefully, because the value is 24 and we have marked as 20, 25, 5 unit difference we have taken. So 24 we have to count according to your graph sheet and you have to mark. For this graph sheet it comes almost here. So when we join, we will get a line, and as before we have to go for verification. Same point 0, 0 I'm taking. When I put 0, left side completely 0. So 0 less than 240. A true statement is getting. That means below the region is wanted. Label the line 10x plus 8y less than or equal to 240. And there are two common constraints are there. That is x greater than or equal to 0, y greater than or equal to 0, or greater than or equal to 0. The region which satisfies these two inequalities is the first quadrant. Then now you have to observe all these four lines regions, and we have to find out the common region. The common region we have to shade. This is the common region for four inequalities, which satisfies the four inequalities. Next we have to go for finding the corner points. Here there is one point, and here there is another point, and this is the third point, and here it is the fourth point. So when we mark, first one is 0, 25 we will get. Second one we will get as 8, 20. So 8 in the sense here comes almost, so that is 8 and 20. And third point is 0, 24. So here 24 is there. So 24, 0 is the third value, and 0, 0 is the fourth one. So collect all these points and put it in a corner points table. So corner points are 0, 25. then next is 820, and next is 24 0. As I said before, 0 0 is not necessary to take. Even if you take also, it's not a problem. And 0 25, if you substitute in z is equal to 5x plus 6y, x is 0, y is 25. So this term is 0, then 6 into 25 will get us 150. The next is 8 comma 20, x is 8, y is 20. So 5 into 8 plus 6 into 20, that is 160 will get. Next is 24 0. 24 0 in the sense 5 into 24 plus 6 into 0. So 5 into 24 plus 0 in the sense we will get as 5 into 24, that is 120. And we have to find out the maximum value among all these three values. So it is quite clear 160 is the maximum value. So label it. Then we have to go for conclusion. Profit will be maximum if company produces 8 souvenirs of type A. X value is 8 here. So 8 souvenirs of type A and 20 souvenirs of type B. And the maximum profit is rupees 160. So this is the solution for the given question. Next we shall discuss question number 8. A merchant plans to sell two types of personal computers, a desktop model and a portable model that will cost rupees 25,000 and rupees 40,000 respectively. He estimates that the total monthly demand of computers will not exceed 250 units. Determine the number of units of each type of computers which the merchant should stock to get maximum profit if he does not want to invest more than rupees 70 lakhs, and if his profit on the desktop model is rupees 4,500 and on portable model is rupees 5,000. So we have to find out the answer, and for that we have to go through the question once again in detail. A merchant plans to sell two types of personal computers. The question is dealing with the two types of computers. The first one is a desktop model and another one is a portable model. And the desktop model will cost rupees 25,000 and portable model will cost rupees 40,000. And he estimates that the total monthly demand, so maximum demand, it will not exceed 250 units. And determine the number of units of each type of computers which the merchant should stock to get the maximum profit if he does not want to invest more than rupees 70 lakhs. So his investment is within rupees 70 lakhs. And profit on each type is given. The first type it is 4,500 and the portable model, that is the second type, it is rupees 5,000. So let's take x and y. Number of desktop model be x and the number of portable computers be y. So let's write down the given conditions. So here no need to make that column and write because the conditions are quite clear and simple conditions. So it is easy, directly we can write. Monthly demand of both the items, it is given to you here 250 units. Means x and y when we add, we will get less than or equal to 250. So that is the condition, x plus y less than or equal to 250. That is the first condition. And next is cost of a desktop computer is 25,000 and the cost of that portable model computer, that is 40,000. And he estimates that the total that we have written the inequality x plus y less than or equal to 250 units. Then determine the number of units of each type of computers which the merchant should stock to get maximum profit if he does not want to invest more than rupees 70 lakhs. That is our second condition. First condition we have taken here, and the second condition, maximum investment is rupees 70 lakhs. So per computer value is given to you here 25,000 first type and 40,000 second type. And the condition will come like this. Maximum investment it is given to us 70 lakhs, and the condition will go like this. 25,000 desktop computers, per desktop computer we have to pay 25,000, and we are going to buy x number of desktops. So 25,000 into x plus per computer portable model 40,000, and here y number we are buying. So y 40,000 into y. So when we add these two, we will get the total amount spending for computers. And according to his estimate, it should not exceed 70 lakhs. Means it should be within 70 lakhs, that is less than or equal to 70 lakhs. And here we can cancel the common terms and we will get as 5x plus 8y less than or equal to 1,040. 1400. So this is the another inequality we are getting. And this is a quite simple question, and let's write the profit on each desktop. We will get as rupees 4500, and portable model profit is rupees 5000. Then we have to maximize z is equal to 4500 into x desktops. So 4500 into x plus 5000 into y portable computers. So 5000 into y. So we have to maximize this equation. Subject to constraints, x plus y less than or equal to 250, then 5x plus 8y less than or equal to 1400, and two common constraints, x greater than or equal to 0, y greater than or equal to 0. As before, there are four inequalities. We have to plot it and represent it on the graph sheet, find out the corner points and substitute it into the equation and maximize it. Now let's find out the table of values. First equation, x plus y equal to 250. So x and y values we have to find out. First we put x is 0, so y we will get as 250. It is a simple equation, easy to calculate. So y if you put 0, x is equal to 250 will come. Next equation is 5x plus 8y is equal to 1400. So here x is equal to 0, if you put this term will be completely 0. So 8y is equal to 1400. So y is equal to 1400 by 8. So we will get as 175. So you have to do the calculation and write down the answer. Don't simply copy the answer. Then y if you put 0, 8 into 0 that is 0, 5x is equal to 1400. So x is equal to 1400 by 5, that is 280 will come. Then common constraints, x greater than or equal to 0, y greater than or equal to 0, that we can directly plot. So let's plot these things on the graph and find out the region. X and y axis we have drawn, and we have taken the points as 50, 100, 150, 200 up to 450. Then next is 50, 100, 150, 200, 250 up to 400. And next let's plot the points. First point when we plot here, it is 0 to 50. 0 to 50 is here, this one, and next is 250 0, that is here. So directly we have drawn the line, and let's find out the region which satisfies the inequality x plus y less than or equal to 250. So let's take a point 0 0, and if you take 0 0, 0 less than 250 will come. A true statement we will get, means below the region is wanted, and label the region x plus y less than or equal to 250. Then next is 0 175. 0 175 will come here. In 175 is between 150 and 200. And next is 280. 280 comes almost here. So just plot the points and draw the line, and we will go for verification with 0 0. And if you put 0 0 here, left side will be 0, 0 less than 1400, true statement, and below the region is wanted, and label the region 5x plus 8y less than or equal to 1400. Then x greater than or equal to 0, y greater than or equal to 0, both equations will satisfy the first quadrant. Then the common region for all these four inequalities are this portion, and we have to shade, and corner points we have to mark here 0 175, and next here there is a common point, that is 250 here from 200, and this is 50, so 250 comes here, and the third point is here, and that we have to label, that is 250 0, and finally the last point 0 0. So let's write down the corner points 0 175, 250, then 250 0. 0 0 is not necessary because we have to maximize, so it should be greater than 0. Then 0 175, if you substitute in equation 4500x plus 5000y, so first term will be 0 plus 5000 into 175. 5000 into 175 if you multiply, we will get 875000, 8,75,000. Next 200 150, x we have to substitute 200, y we have to give 50. So 4500 into 200 plus 5000 into 50. When we do the calculation, we will get 1150,000. Then it is 11,50,000. Next is 250 0. X is 250, Y is 0. So 4500 into 250 plus 5000 into 0. So second term will be 0. 4500 into 250. We will get as 112500. So 1,12,500. Then when we go through these three values, the maximum value is the second one. So 250 is the point here, corner point here. So let's write the conclusion. The profit will be maximum if company produces 200 desktops and 50 portable computers. X is 200, Y is 50. So 200 desktops and 50 computers, and the maximum profit is 11,50,000. Next, we shall discuss question number 11. The corner points of the feasible region determined by the following system of linear inequalities: 2x plus y less than or equal to 10, x plus 3y less than or equal to 15, x comma y greater than or equal to 0 are 0, 0, 5, 0, 3, 4 and 0, 5. Let z is equal to px plus qy, where p comma q greater than or equal to 0. Condition on p and q so that the maximum of z occurs at both 3, 4 and 0, 5 is. Four options are there: p equal to q, p is equal to 2q, p is equal to 3q and q is equal to 3p. So here the corner points of the feasible region. This feasible region means what we use to shade the region which satisfy all the inequalities in a given question. That is called the feasible region. Usually we used to shade the feasible region only, and in the question I used to tell that is a wanted region. Here feasible region, just to keep it in mind, the word feasible region. Feasible region in the sense it is a region which is common for all the inequalities, determined by the following system of linear inequalities: 2x plus y less than or equal to 10, x plus 3y less than or equal to 15, x comma y greater than or equal to 0. Corner points are there: 0, 0, 5, 0, 3, 4 and 0, 5. And here we have to find out the condition, that is z is equal to px plus qy is the value given to us, equation given to us, p comma q greater than 0. Condition on p and q so that the maximum of z occurs at 3, 4 and 0, 5. So the condition or the relation between p and q we have to calculate, or we have to find out, and the maximum of z occurs at these 2 points 3, 4 and 0, 5. So it's a quite simple question. Just let's write down these corner points and z. So corner points given to us is 0, 0, 5, 0, 3, 4, 0, 5, and the values of z also we have to calculate. It is not given to us. So equation is there: z is equal to px plus qy. So we have to put x0, y0. That means here when we put x0, y0 in the sense z is equal to 0 will get, that we have to write. Then x5, y0. x5, y0 in the sense this is gone, and here will get us 5 into p, because x is 5. So 5p it is written. Next is 3, 4. X is 3, y is 4. So here we will get us 3p plus 4q. That is written here, 3p plus 4q. And next is 0, 5. X 0, y is 5. So first term gone, and we will get us 5q because y is 5. So we have got. Now the given condition for us is z is maximum at both 3, 4 and 0, 5. Means 3, 4 is here and 0, 5 is here. So z is maximum at these 2 points. So maximum value of z occurs on 3, 4 and 0, 5. The value on 3, 4 is equal to value on 0, 5. Both values must be same because it is given to us. With these 2 points we get the maximum. And here 3p plus 4q is equal to 5q. Then we will get 3p is equal to this 4q we can bring to the right side, that is 5q minus 4q, that is 3p is equal to q. So let's see here, 3p is equal to q is here. So 3p is equal to q, that is option number D. So value of z will be maximum if q is equal to 3p, That is the way it is given to us, even though we got 3p is equal to q. So D is the correct answer. Next we shall discuss example number 9, a diet problem. Diet problem in the sense something which is related to food habits. So a dietitian has to develop a special diet using two foods P and Q. Each packet means per packet 30 gram of food P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. And each packet of the same quantity of food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol and 3 units of vitamin A. The diet requires at least 240 units of calcium, at least 460 units of iron and at most 300 units of cholesterol. How many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of vitamin A? So here I will just explain the question and you will do it as homework. You have to form the inequalities and you have to plot it in a sheet of graph and you have to complete it as homework. Here a dietitian has to develop a special diet using two foods P and Q. It's about two foods P and Q. And P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. Four parts are there. First one is calcium, iron, cholesterol and vitamin A. So the unit requirement is given to us 12 units calcium, 4 units iron, 6 units cholesterol, 6 units vitamin A. And in case of food Q, also 30 gram only food Q contains 3 units calcium, 20 units iron, 4 units of cholesterol and 3 units of vitamin A. And the diet requires at least 240 units of calcium. Here at least keywords must be very careful. Here more than two inequalities we have to form. So I have to go through the question very clearly. The diet requires at least 240 units of calcium. At least in the sense minimum 240 units. Means when you write the inequality, we have to use the symbol greater than or equal to. Means at least it is given. At least means minimum 240. So above 240, how much also it is not a problem. But less than 240, it should not come. So minimum 240 in the sense you have to use the symbol greater than or equal to. Here also at least 460 units. At least means minimum 460. So inequality symbol we have to use is greater than or equal to 460. But when it comes here, at most 300 units of cholesterol. At most means maximum. Maximum 300 means you should not exceed 300. So you have to use the symbol here less than or equal to. So in case of at least you have to use greater than or equal to. In case of at most you have to use less than or equal to. So how many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of vitamin A? So here the minimizing question it is. So you have to assume x and y, then we have to formulate the inequalities, then find out the minimum value. So you will try it as homework. Next we shall discuss the miscellaneous exercise. First problem. A dietitian has to develop a special diet using two foods P and Q. Each packet containing 30 gram of food P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. Each packet of the same quantity of food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol and 3 units of vitamin A. The diet requires at least 240 units of calcium, at least 460 units of iron and at most 300 units of cholesterol. How many packets of each food should be used to maximize the amount of vitamin A in the diet? And what is the maximum amount of vitamin A in the diet? Previous question only the last part is different. So example number 9 we have already explained in the previous slide, and there we have to minimize and here we have to maximize. That's all. So the question I have explained to there clearly. So the same thing only here also. So here telling about two foods, food P and food Q, and the components are given 12 units of calcium, 4 units of iron, 6 units of cholesterol and 6 units of vitamin A. Here vitamin A we have to keep aside because we have to find out maximize how much, that in equation we have to make. For that this vitamin A we will keep aside. And in the second case also same thing, vitamin A we will keep aside, and by using the remaining three components we will form the inequalities. So let's assume x and y, number of packets of food P, be X, and another type is food Q, that is Y. Then write down the main points. There are three components: calcium, iron, cholesterol, that we have to write. Vitamin A we will keep aside. So calcium, then next is iron, next is cholesterol, and in case of food P, 12 units of calcium. So requirement: P contains 12 units of calcium and 4 units of iron, then 6 units of cholesterol, and next is food Q contains 3 units of calcium, then 20 units of iron, then 4 units of cholesterol. Vitamin A will keep aside. And maximum requirement: the diet requires at least 240 units of calcium. The word at least I explained to you before. At least means minimum. Minimum 240 means above 240 how much also not a problem. So according to the condition here. So above 240 is the requirement. Means at least means we have to use greater than or equal to. So total requirement is at least 240 units. Here total requirement is at least 460 units, and in case of cholesterol it is at most 300 units. So let's write the inequalities here. 12 into x number, 3 into y number. So 12x plus 3y at least means greater than or equal to. Remember keyword at least, you should use greater than or equal to. At least means minimum 240. So you have to go above 240 for the requirement. So greater than or equal to 240. Here common terms are there. 3 is common. Just cancel it. 4x plus y greater than or equal to 80. And here also at least only. So symbol we use, inequality symbol is greater than or equal to. So 4x plus 20y greater than or equal to 460. Then cancel it. 4 we can cancel. X plus 5y greater than or equal to 115. Next is 6x plus 4y less than or equal to 300. At most means maximum 300 you can use. You should not exceed 300. So within 300 we have to stand. That is less than or equal to. Remember at least means greater than or equal to. At most means less than or equal to. Then 2 we can cancel. 3x plus 2y less than or equal to 150. Then we have to go for what we have to maximize, that we have to find out. We need to maximize the amount of vitamin A in the diet. That is food P contains, we kept aside some quantities there, 6 units of vitamin A that we are writing. Then food Q contains here 3 units of vitamin A. So that it is written. Then let's write the equation is Z is equal to 6 into X plus 3 into Y. So maximize Z is equal to 6x plus 3y. Subject to constraints, write all the inequalities. 4x plus y greater than or equal to 80. Next is x plus 5y greater than or equal to 115. Next is 3x plus 2y less than or equal to 150. And common constraints, x greater than or equal to 0, y greater than or equal to 0. So we have to plot all these 1, 2, 3, 4, 5 inequalities are there. All these 5 inequalities you have to plot it on a sheet of graph, and we have to find out the feasible region or wanted region for all these inequalities, and we have to find out the solution. Next, let's find out the table of values. First one is 4x plus y is equal to 80. Then x, first we have to put 0. X 0 means y is equal to 80 will be getting. Next is y 0. If I put 4x is equal to 80, x is equal to 80 by 4, that is 20. Next is x plus 5y is equal to 115. Then we'll go for putting x is equal to 0. X is 0 means 5y is equal to 115. Y is equal to 115 by 5. We will get as 23. Then usually we put y is 0. Y 0 means we will get x is little bigger value 115. So the gap is too high. So we will reduce it. Then just to put y is equal to 9. You can put any other value. It's not a problem. Just to see x values. If it is too much difference is there means it will not stay in a sheet of graph. So we have to reduce it. Here I am putting x is equal to y is equal to 9. Y is equal to 9 if you put 5 9 into 5. 9 into 5 in the sense 45. So x plus 45 is equal to 115. X is equal to 115 minus 45. 115 minus 45 is 70. That is okay because here 80 also is there. Then 3x plus 2y is equal to 150. Next equation, x and y. X0 if I put 2y is equal to 150, y is equal to 75 will come. And y0 if you put 3x equal to 150, x is equal to 150 by 3, that is equal to 50. So both values is not a problem. 0, 0 is fine. Then let's plot it. These inequalities in a sheet of graph. X and y axis we have taken, and here x values 10, 20 up to 70 we have taken, and y values up to 80, 0 to 80 we have taken. Then let's plot it 0, 80. So 0, 80 in the sense the first point is here, you have to mark it. Then next is 0, 20. 0, 20 is here. So join these 2 points and take the verification point 0, 0. We put 0, 0 means here less than or equal to, sorry, greater than or equal to 180 is coming. 4x plus y greater than or equal to 80, that is our inequality, should not confuse. Then 0 plus 0, that is 0 greater than 80 is coming. 0 greater than 80 is wrong, means it is a false statement, means this is not our feasible or wanted region. We have to go another side, opposite side, so that we have to mark. Then inequality also we have to label. Next is 0, 23. Here 0, 23 comes between 20 and 30, somewhere here. Next is 79. 70, then we have to go 9. That 9 means close to 10. So you have to count. Here there are 10 lines are there, small lines are there. So I am taking exactly here. And according to your graph sheet, you have to draw the or plot the points. So join these 2 points. Then take a point for verification. This is the point 0, 0. When we take 0, 0, here the inequality symbol is here greater than or equal to. So here also 0 greater than or equal to 115 will come. So 0 greater than 115 is a wrong statement or a false statement, means below the line is 0, 0. So below the line is not a feasible region or not a wanted region. So above the line is required one. So we have to label the inequality x plus 5y greater than or equal to 115. Then just please note that comparing to the previous questions, this is somewhat a tricky question because greater than, less than and all coming in between. So be careful when you do. Next is 0, 75. Here is 0, 75 comes here between 70 and 80. Next is 50, 0. 50, 0 is here. So just draw the line. Then as before we can take a point 0, 0, and here 3x plus 2y less than or equal to 150, that is our inequality, remember that one. And 0, 0, if you put 0 less than 150 will come, so it is a true statement. So the below the line is required one because 0, 0 lies below the line. Then label the inequality x plus 2y less than or equal to 150. Then again 2 more inequalities, common inequalities, x greater than or equal to 0, y greater than or equal to 0. The feasible region is first quadrant. And the common region for all these 5 inequalities we have to shade. Then write down the common points, corner points, a 272 here. So be careful when you count, exact counting should be there. So because here in between the lines the points are coming, so 272, that is the point here. It is quite visible here, second line. Then next is here there is a point that is 40, 15. Then 15 means between 10 and 20, it's clear here. So we 40, 15, and the third point is 15, 0. This is 15, between 10 and 20 there is 15, and here 20, 15, 20. So when you draw, you must take utmost care while taking these corner points, or else you will not get the correct answer. Then corner points you have to write 272, 40, 15, 15, 0. Then z is equal to 6x plus 3y is our equation. When you put 6 into 2 plus 3 into 72, so we'll get us 228. Do the calculation. Then 40, 15, x is 40, y is 15. So 6 into 40 plus 3 into 15. When you do the calculation, you will get us 285. Next is 15, 20, x 15, y 20. 6 into 15 plus 3 into 20 will get us 115. Then the maximum value is here 285. So write the conclusion. You can say amount of vitamin A will be maximum if 40 packets of food P and 15 packets of food Q are used. Next we shall discuss question number 4 from the miscellaneous exercise. A manufacturer makes two types of toys A and B. Three machines are needed for this purpose and the time in minutes required for each toy on the machines is given below. There is a table, types of toys A and B, mission times also given 12 minutes, 18 minutes, 6 minutes, 6, 0 and 9 minutes respectively. So we have to go through the question. Each mission is available for a maximum of 6 hours per day. If the profit on each toy of type A is rupees 7.50 and that on each toy of type B is rupees 5. Show that 15 toys of type A and 30 of type B should be manufactured in a day to get maximum profit. So it is quite simple because it is given to us in a table. So it is not necessary to read 2 or 3 times because the main contents are here in the table. But for some other inequalities we have to write by using these conditions. So we have to go through it once again. A manufacturer makes two types of toys, toy A and toy B. Three machines are used. It is given machine 1, machine 2, machine 3 and time in minutes also given. Each machine is available for a maximum of 6 hours per day. So each machine is available or each machine can use maximum 6 hours in a day. And the profit is given and we have to find out, we have to show that here the question is asking to show that 15 toys of type A and 30 of type B should be manufactured in a day to get a maximum profit. And when something is asked to show, it is quite difficult in the sense if your corner points are not correct, you will not get the answer. So you have to be very careful when you write the inequalities and plotting the points. Here, let the number of toys of type A be X and number of toys of type B be Y. And let's write the main points. Machine 1, machine 2, machine 3. Three machines we are using. And from here we can pick and write. That is time required. Type A, that is 12 minutes. And type B, 6 minutes. Machine 1 for type A 12 minutes and for type B 6. And machine 2, type A is 18 minutes and type B is 0 minute. And machine 3, here machine 3, 6 and 9 minutes. So you have to write 6 minutes and 9 minutes. And here the maximum available time. Each machine is available for a maximum of 6 hours per day. Means we have to write 6 hours. 6 hours in the sense the given conditions are in minutes. 6 into 60, that is equal to 36 minutes. Converted hours to minute. And each machine is available. Means all three machines also 6 hours only. So here also 360 minutes and here also 360 minutes. Let's write the inequality. 12 into X plus 6 into Y is maximum available time. Maximum means it should not exceed 360. Means less than or equal to 12x plus 6y less than or equal to 360. There is common quantities available. We can just divide with 6. So 2x plus y less than or equal to 60 will get. Next is 18 into x, 0 into y less than or equal to 360. 18 is common, that is x less than or equal to 20. Here 0 is there, so it's no need to write. Next is 6 into x plus 9 into y is 6x plus 9y less than or equal to 360. So when you cancel it, 2x plus 3y less than or equal to 120. 3 we have to cancel. So 2x plus 3y less than or equal to 120. This is the third inequality. Then profit on type A is given to us 7.50 here. The profit on type A is 7.50 and type B is rupees 5. And we have to maximize. Z is equal to 7.50 into X plus 5 into Y. This is the equation. So next we have to go for writing out the table of values. Before that, let's write all the inequalities so that it is easy for us to draw if it is visible in one slide. So maximize Z is equal to 7.5x plus 5y. Then subject to constraints 2x plus y less than or equal to 60, x less than or equal to 20, 2x plus 3y less than or equal to 120, and common constraints x greater than or equal to 0, y greater than or equal to 0. So these are quite simple things, just we copied from the previous slide, that's all. Then let's write the first equation 2x plus y is equal to 60. And here x is 0 if I put, y is equal to 60 will come, and y is 0 if I put 2x is equal to 60, x is equal to 60 by 2, that is 30. Next is 2x plus 3y equal to 120. Then x is 0 if you put 2 into 0 plus 3y. So 3y is equal to 120, y is equal to 120 by 3, that is 40. Next y is 0 if you put 2x is equal to 120, x is equal to 60. Then just plot these things in a sheet of graph, x and y axis, 1020 up to 70, and here 1020 up to 80 we have taken. Plot the points 0 60. So here 0 60, first point is here, then 0 30 it is here. So just draw, and let's verify it with 0 0. When we put 0 0, 2x plus y less than or equal to 60 means 0 less than 60 will come. 0 less than 60 is a true statement. So the below the region is feasible. So 2x plus y less than or equal to 60 we have labeled. Next one, x less than or equal to 20. In the sense x is equal to 20, that is the equation. X is equal to 20 in the sense here is the point. Just there is only one variable x. So just draw a line cutting the x-axis parallel to y-axis. That is what x is equal to 20 line. And we have to verify the region. So as before, x less than 20. X less than 20 in the sense it is quite clear. X less than 20 means left side of this line. Right side means it is 21, 22, 23 it will go. So left side of the line is feasible. So we have labeled. Then next is 0 40. 0 40, the point is here, and 60 0, the point is this one. Plot and just join it and take a point 0 0, and when you put 0 less than 120 will come. 0 less than 120 means it is a true statement, means below the region is wanted, and label the inequality. Then x greater than or equal to 0, y greater than or equal to 0. Common region is first quadrant. The feasible region satisfying these two inequalities is first quadrant. And where all these inequalities 1, 2, 3, 4, 5 inequalities together satisfying the region this one, and that portion you have to shade, that is the feasible region for all these 5 inequalities. And let's write the corner points here. A 0 40, next is here it is 15 30, that is 15 30. Then next point is this one, here there is a point, and that is 20 20. This is 20 and this is 20. And next point is here 20 0. And of course there is a fourth point, that is 0 0. Not necessary to take. Even if you take, it's not a problem. Corner points we have taken 0 40, 15 30, 20 20, and 20 0. And when you put it here, 7.5 into 0 plus 5 into y. 5 into y in the sense 5 into 40, that is 200. This term will be 0. Next is 15 30. 15 30 in the sense 7.5 into 15 plus 5 into 30. When you calculate, you will get 262.50. Please do the calculation and simply don't copy from here. Next is 20 20, that is 7.5 into 20 plus 5 into 20, that is 250 when we add. 20 0, 20 0 in the sense x 20, y 0. So 7.5 into 20 plus 5 into 0. So we will get as 150. And we have to find out the maximum value. Maxima is z is equal to 7.5x plus 5y. So the maximum value is here 262.5. And let's go for the conclusion. Hence the profit will be maximum if the number of toys of type A 15 and number of type B toys, that is 30. So this is what we have to prove. And finally the maximum profit is rupees 262.50. So that is the conclusion. Dear students, today we have completed exercise 12.2 and solved first 4 questions from the miscellaneous exercise. And we have excluded some questions, that is as per the CBSE norms. Hope it is clear for you all, and I request all the students to go through the questions and solve it separately in a sheet of graph. And while solving, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.